We were talking about inverse trig, right?
Yes, ma'am.
Okay. Question. How many different ways are there of writing inverse trig? 2. One way puts one little 3 letters in front. What are they? Arc. Arc sine, arc cosine, arc tangent, arc cosecant, arc secant, arc cotangent. What's the other way to show inverse?
Cosine
with the little -1. But what does it not mean?
The reciprocal secant.
Doesn't mean secant or cosecant. Doesn't mean reciprocal, right? Okay. If we were talking about an arc trig function, okay? Remember really quickly, trig comes from triangles, right? The TRI at the beginning. Trig comes from triangles. And what kinds of triangles specifically? Right triangles. Right triangles that have a theta, have an opposite, have an adjacent, and have a hypotenuse. True? Okay. So if that is the triangle that we're working with, and if we have our SOHCAHTOA CHOSHCAHTOA without going into all of the craziness, right? Question. Is SOHCAHTOA CHOSHCAHTOA for the normal trig or the inverse trig? Why normal?
Because when you're using inverse trig, they're giving us a place and we have to find the angle instead of using the angle to find it.
To find like a ratio. So SOHCAHTOA says, if you want sine at an angle, I can find it for you. Draw the triangle at the angle, and what's the answer to the sine? Opposite over hypotenuse, right? So SOHCAHTOA CHOSHCAHTOA says, okay, if you want a sine of an angle, I'll give you opposite over hypotenuse or adjacent over hypotenuse for cosine, etc., etc. Arc trig or inverse trig says, let's go backwards, right? Now, when you guys were down here in your unit circle, and when you found 5 pi over 3, where do you end up being? Quadrant 4. And at over 3, is that a big angle or a little angle? Smaller than 90, but isn't it bigger than the 30 or the 45? That's a 60 degree. Here's our 5 pi over 3. We'll come back to him in a second. Down here, where did pi end up being? Oh, we know him. He's over here, right? Okay. Oh, her. Okay. If we're trying to find arc sine of sine of 5 pi over 3 or cosine of cosine inverse, this looks really funny unless we remember how a function and his inverse are related. Do you guys remember that from not a long time ago, but a while ago? If we're dealing with inverse functions, do you guys remember what happens when you take the composition of a function with his inverse? What normally happens? Do you need to see an example? Let's look at an example. What's the inverse of squared? Something squared. How do we invert that or undo that? A square root. So question, what happens when we square root a squared? Oh, the square root and the squared undo each other, right? And we get an x. Now, do you guys remember that he's kind of funny? And that this is always positive, so actually when we undo, we have to kind of do something a little funny and make him an absolute value. It's a little rough. Probably talked about him back in algebra. We haven't talked about him a lot this year. But if it's squared, it's a positive, and a square root is a positive. So when we take it all away, we have to say, you're only allowed to be positive. Okay, that one's a little funny. Let's do another one. There are sometimes special rules about what happens when they cancel. But what about this one? Are they inverses of each other? Yeah. L and E undo each other. What's left? So question. What happens when you take a function with his inverse, or an inverse of a function? It's going to, reduce or undo all the extra stuff and just be left with x. Now sometimes there are special rules, though, that we have to be considerate of. Like signs, or like restricted domains. So let me give you one more and let's see if we can follow the logic. So what if I was to do cosine inverse of cosine of Except, is there anything special about what comes out with cosine inverse?
Oh,
Anything?
it cannot be between 1 and
So, okay,
cannot be between -1 and 1.
this has to be between 1 and -1. But if it exists, then it's going to work, right? So let's assume that this exists. They didn't give us a trick one. This exists, but still, what comes out has to be in between what and what? For cosine inverse, do you remember? What goes
No,
in?
infinite and -1 to 1 to infinite.
That's for tangent inverse. Careful. What goes into cosine inverse? Hold on. Go find them in your notes. It's okay. Go find cosine inverse. We wrote it down. Domain. What goes in is in between 1 and -1. What comes out is in between 0 and, do you find it? Pi. So we have to add this little extra, kind of like with the square root squared thing, there was an absolute value. We have to add a little extra and say, ooh, x is only allowed to be in between.
This is
Now, why is that weird?
just the horizontal.
The x is in the cosine, and that goes inside the cosine inverse. So some of you guys thought x and thought domain, but it's really what's coming out of the cosine inverse, which is why it's in between those two angles. Now, did it at least make sense though that those two kind of cancel the same way those canceled and those cancel? Okay, so hold on, let's go back here. So question. If we're looking at this now, we say, oh wait, one's an inverse, one's a not. Sweet. Dun, 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 dun. But I'm wrong. The idea is right, but I did something illegal. Go back and look at arc sine or inverse sines restrictions. What's allowed to come out? What angles are allowed to come out of arc sine? Only up pi over 2 and down pi over 2. If you're only allowed to go up 90 and down 90, am I allowed to go all the way to 5 pi over 2? I have to go this way. Now, it's the same place. It means the same location. But that's illegal to put because arcsine can't have that as an answer. The only answer it can have is getting there the negative way. And some of you already said it. What angle would it have to go negatively to get to that one? So it's like I'm canceling, but I have to remember, just like we kind of did for the rest of the section, the legal values I'm supposed to be looking for. And the only legal value, the only legal way to get to this same exact location is negative pi over 3. But why? Because arc sine is only allowed to use what angles? These ones. Now hold on, let's go to the next one. As soon as you see a cosine inverse, wait a minute.
Domain is -1 and 1. What did you say?
Yeah, cosine inverse is allowed to get. Wait a minute.
Yeah, but cosine is pi to 1 and 2, so it's
So that
fine.
would work.
It is fine, except is pi coming out of the inverse or is it going into the inverse? Oh, they put that to trick us. Hold on, what goes into the inverse cosine? That's domain, right? Hold on, Delani, you said it. What are the numbers I'm allowed to put into a cosine inverse?
Oh, no, 0.
0,
No, you were right the first time.
-1.
You're only allowed to put in -1 to 1.
Oh, that's 3.
That's 3.1415926, cheaters.
So then it doesn't
They
matter.
made me think it was an angle, but cosine inverse,
Who are they?
-1 to 1 goes in, angles come out, little cheaters. Now, if we looked at it fast, we would know the idea if we did that. We're kind of tracking. But the problem is because of this whole extra domain and range thing. Can you guys plug this in your calculator real quick? If you believe me, the answer should be error. If you believe your quick math of cross out pi, well then you guys would be right. It would be 3.1415926. What happens when you do cosine of cosine inverse of pi? Error. Because was pi allowed to go in?
Actually says domain.
Domain, exactly, right? Because pi wasn't allowed to be in the domain of cosine inverse. So, some problems are totally legal for you guys just to cross out and say answer and cross out and say answer. But I need you guys to understand, even though the idea is, hey, an inverse of its original function does cross out. Even though that's the idea, are there special rules we can't forget? And sometimes will they mess us up? Now, can I give you an easy example? Is that cool? We did 2 hard ones. Let's do an easy one. So what if I was to give you something like C? I don't know. Let's do tangent inverse of tangent of pi over 4. I want you guys to make an initial guess that I want you to plug into your calculator and see if your guess was right. You might have to kind of figure out the decimals. But make an initial guess. Thinking about your rules, maybe. Make an initial guess. And then plug and chug it to your calculator and let's see if it agrees with you. And similarly, if you agree with it. And technically, if there's a pi over 4 going in as an angle, that should be in radian mode, right? Just to make sure. What was your initial guess? What do you guys think? Pi over 4. Cancel it out. Easy answer. All right, what happened when you plugged into your calculator? Decimal. Okay, well, what is pi over 4? Did you check that next? Did it work? Perfect. So sometimes is it easy? Yeah.
So if you know it works,
If you know it works, just go straight to answer, right? But if it's outside, if an angle that would go into arcsine, or that would be the answer to arcsine, if the angle's outside, oh, we're going to have trouble. We have to match it up. And if a number bigger than the range in between 1 and -1 is going into the inverse, well then that's illegal too. There are 2 different ways I might get messed up. One is illegal. One is a number that's too big for my inverse. The other one says, this guy's not the right one. Let's go find one that means the same thing but is legal in my interval. That's one way, or that's one type of thing you might see. I think that was kind of like the first thing you came to after you were just doing the inverse trig, solving from the unit circle. There's one more though. This one gets a little funny. They might ask you to actually set up a triangle. Do you guys see that in homework at all? And so we just kind of have to remember what's being given to us in order to be able to set up those triangles. We have to remember what's being given to us. And even though it's a tricky problem, it helps us understand more of the inverse trig and what it means. As soon as they say set up triangle, we say, okay, fine. Make some sort of generic right triangle. There it is. But how do we label said triangle? Well, it says couldn't that be like, well, with sine? Sine has to do with opposite over hypotenuse. So the fraction would help you label the triangle. Good. If it's arc sine, that's a ratio. If that's arc sine, that's a ratio. You put in a ratio, you get out an angle from arc sine. And what is the ratio? Well, opposite must go with, if I'm thinking about just what I could make each, opposite could go with x. Hypotenuse could go with 2. Oh, wait a minute. We have to choose an angle, right? Well, choose some random angle. Doesn't really matter. You just need to make his opposite be
2. And then x.
Oh, x. Does that make sense?
Yeah.
And then his hypotenuse be 2. Wait a minute. So this whole clue just helps me set up the triangle?
only 2 sides though.
Yeah, that's a problem. Why? What are they asking me to find of this triangle?
Cosine.
Oh, and cosine is who?
Adjacent over hypotenuse.
Well, that's no good because I don't have an adjacent.
But can we
Yeah.
set up like a
And what formula are we going to use to set up an equation to solve for? You don't like that? Here, let's do like A. Can I do A instead?
Did we have an equation in 4.5 for this?
In 4.5. For the sinusoids? Not for triangles. How do we solve for a side if we know 2? Now some of you are like, well, we don't know him. How do we solve for a side? A squared?
Plus b squared equals c squared. Or
But
x
it's
squared.
not gonna take you anywhere.
Because we're missing 2.
But we were missing from the beginning. Maybe x is allowed to stay. Maybe it's going to be a formula and not a number. Well, if x is allowed to stay, who's probably the one guy that's not allowed to stay? The random one I made up. But can I solve for the random one I made up?
Sure. Why not?
2 squared is 4. Subtract the x squared to the other side. And to get a by itself, can't I just...
This was on the homework. That's the one I didn't pick up. Perfect.
It's weird, right?
Yeah.
I can solve for a with a plus or minus square root.
Got it. That's what I'm trying to figure out.
And then it's a plus because measurements can
And then
be
you can
negative.
set it. Oh.
Well,
That was the answer.
We're talking about triangle.
yeah,
If
that's
it
my
goes
a,
in
right?
unit circle,
Yeah.
it
So
could
then-
be negative.
I need my adjacent, but who is my adjacent? That guy. Now, I know some of you are thinking about signs. Hold on, give me 1 second so I can talk about it. But right now, I'm just saying, who's A? That guy. And
X is
who's-
okay.
Yeah, X is okay because, well, there was an X to begin with. They didn't give me numbers, so how can I give them numbers? I can't. I can give them a formula. So, X stays. I have my adjacent. Oh, wait. But who do I need to put him over? Hypotenuse, which is 2.
Oh, because it's cosine.
Now, the way that this question was given to you, do you honestly know exactly where in the unit circle this is, so whether it should be a positive or negative? They didn't tell us anything about where it was. So right now, I'd have to stop and box it. Now question, what if they added an extra little piece? And let's say, this was the first one. Cool, we got the formula for cosine. But let's say they were then, to give us an extra direction, solve for theta between pi over 2 and pi. What if they did give us an extra clue? That did or should put us in a particular part of the unit circle. Question, where is pi over 2 to pi?
According to.
Good. So if I'm in here somewhere, where? I don't know, it depends on who x is. But if I'm in here somewhere, what would I have to choose as the sign for cosine and sine?
Negative or cosine.
All students. Sine is positive,
So then that means
cosine is.
the square root of 2 over 2 is then negative.
Yeah, I need a negative. Now hold on. Nobody take that top square root. How come? I know you want to. I know you want to make it nice and pretty and actually take it. But what would you be killing in the process? Yeah, you can't take little square roots of binomials that are squared because wouldn't he factor to be 2 plus x times 2 minus x? Those aren't the same thing.
Bummer.
I know. So just keep him the way he is. It's okay to have a square root in there if he can't be simplified. And he's up top, which means it's nice and pretty. Weird, but possible. We just had to know 2 things. X can stay, right? And second of all, that was used to label signs.
It's one of those answers that in the test you're looking at it and it's like,
What to do, what to
I
do?
don't know if this is right.
Yeah, it's one of those that is just like, okay, I think it's right.
You say what where?
If it's multiple choice, hopefully one looks like it, right? All right, so you guys try one. Go. Let me have you try another one. Careful, this time it's art secant. Chosha cow. Who are those guys? The directions: using a triangle, solve for a formula of tangent. Using or setting up a triangle, solve for the given interval of negative pi over 2 to 0. remember, since they gave you angles, you should be able to figure out which side. Just think about your units. What sides did you guys label? Nice. Because our secant, this should have been sh, right? Hypotenuse. Because it's take cosine and flip it. Can I put a B? I don't like O for opposite. I'm gonna put a B instead. Let's see if you guys did your math carefully with 2x squared.
It goes 4x squared.
4x squared. Help me out. Save the puppies. Can you go any further with the square root?
It's not.
Because the factors would be 2x plus 3, 2x minus 3. We gotta stop. That was good work if you got that far. But what or how are we supposed to use that triangle? What are we supposed to find from that triangle? Tangent. You gotta keep looking and say, now it's time for who? Tangent. So check it out. Tangent is who?
Over a.
And who is opposite? This guy. So we can say our final answer. Well, hold on. I'm gonna put the plus or minus, but remember how you guys are supposed to think about what angles those are and what sign tangent should have? But let's give a reason why. Where is negative pi over 2 to 0?
It's quadrant 4.
Negative goes down, right? We're talking about these angles somewhere. These angles. All students take tangent's not positive.
It's close. Cosine that's positive.
Yeah, cosine's positive. So then what must tangent be? Negative. Because of this, I'm going to go ahead and say, no. If you're down there, you're the negative value.
Missy, what if it was in quadrant 3? I
Positive.
would have to change the cosine too, huh? It would have to be a negative 3 cosine. I mean, the adjacent. The adjacent would have to be negative 3.
So you could change each of the pieces in the triangle, or you could just choose the right sign at the end. Technically. Does that make sense? Yeah, so you could make it a negative over a negative, which is a positive, or you could just say, no, I know tangent is positive in the third quadrant, if it was that. All right, does this type of problem make a little more sense now?
Yes.
For those of you that didn't get up this far, hopefully it'll make more sense when you see it. And it won't be as crazy as it was for some last night. There's one more weird thing I have to talk about. And this is one of the things. Oh, that's so easy because it's a calculator question, and yet, so many people frequently miss it. And I'm already promising you it's a question on the test. Not this exact one, but one very similar.
Little star.
It takes very, very little work, and yet, it's so tricky. How to find in your calculator inverse values of secant, cosecant, and cotangent. Because if there aren't buttons for secant, cosecant, and cotangent, there aren't. There are no buttons for cosecant inverse, secant inverse, or cotangent inverse. So we have to know how to use sine inverse, cosine inverse, and tangent inverse to solve. And your gut is going to tell you the wrong thing to do. and deceitful and desperately wicked. Who can know it? Watch out. You can't always trust your feelings or your heart or even sometimes your mind or even your gut. Not saying you can never trust. It's not being brought in submission to the Lord. It's not telling you truth. Okay. How do we find? Now, I'm not going to go crazy into depth. So let's go ahead and just put little negative ones. Okay? I'm talking about inverse. Cosecant inverse. Secant inverse. Cotangent inverse. There's no button in your calculator. What do you think your gut would tell you? How do we normally find cosecant? Oh, 1 over. Oh, so since it's inverse, it's 1 over sine inverse, right? Wrong. Doesn't make sense. Because the angle isn't 1 over. The ratio is 1 over. And the ratio for inverse, is it on the inside or is it what's coming out? The ratio is on the inside. Aw, stink. So we need to take our 1 over clue and say, no, 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 no. The 1 over happens inside the inverse sine. And the 1 over happens inside the inverse cosine. And the 1 over happens inside the inverse tangent. Do you see why it's tricky? If we're finding cosecant, secant, cotangent in our calculator, not inverse, regular. Oh, it's just 1 over the reciprocal. But inverse doesn't mean reciprocal. Inverse means the ratio is the reciprocal. The inside is the reciprocal. So go find me the right answer to this one. And it better not start in your calculator with 1 over tangent anything. Use the formula up above. How do we find arc cotangent of 5.25, which is, remember, the exact same thing as cotangent. Remember the arc? What does it mean?
Inverse. So we can't use 1 over tangent inverse of. Dang, I would
The
make
more
it.
you say it, the more you'll remember it. No, no, no. But right, that's where your gut leads you, right? It makes sense. Totally.
Yeah.
Oh, it's so illegal. As you guys find it in your calculator, I'll show you why. Since cotangent inverse does not equal cotangent inverse, then that does not equal not equal. Why is your brain telling you this? Because it's thinking he's a power. But is he a power? It's much bigger than that, much greater than that, much more unique than that. So that is all illegal.
So in this one, 10.
2 different answers, both of them right, but it only changes based on the mode, not based on how you plugged it in. Someone who's in radian mode that used the formula properly, what'd you get? No? Yeah. Okay, we're on there. Someone in degree mode. Those are both right. 1 over tangent inverse, totally wrong. That'd probably be a multiple choice answer. Okay, we got it? But look how easy it was. If only you knew what formula to use.
With our test, is it gonna be calculated on portions or is it gonna be on our entire test?
We'll say portion right now. Just because I need you just to know your unit circle.
Okay.
That's fine. That's fine. I know, right? So that part should be easy. No big deal.
Take the unit circle and then calculate.
Oh, I'm not gonna put both. It's either all degree answers or all radian answers. So you just have to, like, if you're in one mode and it doesn't match, like, other mode, and then it should. Does that make sense? Woo! All right, we We got it. Parts 1 and 2, it sounds horrible, but remember we deleted all the extra problems. Okay. So I'm moving on. 4-8.
Thanks, Miss Stevie.
Yeah. The reason why I don't want to stress about word problems in 4-7 is because there are word problems in 4-8.
Oh, bye.
You're welcome. But 4-8 could take, listen, 4-8 could take 2 to 3 days. I'm totally bogged down in word problems and just like dig deep. We're gonna have time to deep right now. So we're gonna do the nice. Oh, you want the word? But coming back. Is that gonna mess anyone up horribly? That's Friday. Oh wait, is someone saying that?
Oh, no.
So let's. Okay, listen. Calendar will get updated today. Test Friday. So then next week we're only doing 5-1, 5-2, not 5-3, which is actually nice because these two are. Anyway, it'll cut down a little bit. All right. All right. So we're only going to 5-2. We're only going to 5-2 before the final. But it's chapter 3.
On the final?
Yes. But maybe like one multiple choice, one long answer.
One way, after Stu writing down stuff, I didn't take a picture with Brennan in the times that we did the stuff at home, but Mrs. N just signed it.
Oh, for you helping.
Yeah.
Okay.
We don't
Maybe
have a
can you
selfie.
maybe can you take a picture now with like some of the work he did? Like you guys can just pose with some of the work that was done.
Okay.
Oh, so that's
Yeah.
They worked hard, got parent signature. I would rather have a picture in the morning. Oh, I just break it into half hours because sometimes people can't do a whole, but you can sign two blanks. Or 3. I thought people do 4. So maybe do that.
Which was good.
If you guys do like a FaceTime help, you can always do like a screenshot. Otherwise, you can just take a selfie if it's an off-campus one. Just remember, everyone's talking about those forms online.
Oh, yeah.
If you need to know where to find it, that's just it for the off-campus. If you're on campus, just go tell a teacher, be like, hey, I'm tutoring, or if you're in here, if you're in the library, or if you're with your team and you guys have a study hall and you're working together. Just be like, hey, coach, can you sign off because we worked on math and this is just an assignment I have to do for 3. Is that cool?
Is that, when is that due day? We take our final or is it?
Technically the day of the final.
Okay.
Because I figured that way you guys could be helping each other study for the final or helping little kids study for their final.
Today I'm available after school. Come and just like help. Did you think I'll get some help or something?
I mean, they do. I don't know if they're coming in. I have a Baja meeting
Okay.
until like 4-ish. You can pop into Mr. Park's room. He loves people that help. Or Mr. Che. Or you can be like, hey, does anyone need help on pre-cal? Mr. Che has pre-cal kids. So they might be in there working.
I only
Or
have
else for
final on Thursday and then I'm done.
Yeah.
Because I'm choir and then
Hey guys, what's new? Draw a picture. No, we should know that. Label. We should know that too. Pythagorean. We should know that.
We know all that.
What's this? Sokatoa Choshikau. Wow.
Wow.
So is there anything else?
See ya.
Just words.
Oh.
Alright, here we go. Where is the sun normally?
In this.
In space. He's up. I don't have orange, so I'll do red. It says above the horizon. What is the horizon? Straight line. Horizontal.
Should we really copy those words?
Nah, it's okay.
Yes.
But write number 20, because that's actually a problem number in your exercise. Find the length of a shadow. Shadow. Where's the shadow? On the ground. If there's nothing else there, it's on the ground, right? Okay, so there's something down here. Shadow. Where's the park statue? Could it be right under the sun? There'd be no shadow, right? Doesn't it have to be off to the side of the sun? Okay, so we'll say, yay, park statue, isn't it gorgeous? Okay, there he is. The sun is shining, and as the sun shines, what does it form on the ground? So we're saying the park statue is at 90 degrees. If it's not, it's like Leaning Tower of Pisa stuff, and they better tell us that. So we'll say park statue is 90 degrees. Shadow, I don't know. So we label him with an unknown variable. True? What else can I label? 20 degrees is how high the sun, right? Angle of elevation. Ooh, nice. What else do I know? Oh my goodness, it's like a right triangle problem from the beginning of chapter 4. How are you gonna solve it?
Wait, it's 12 feet from the sun.
Park statue is 12 feet. Oh. That'd be scary. Tangents! Hey, what mode had you better be in? Better be in degrees or else we're in trouble. Algebra tells us, how do we solve? Some of you messed this up, so let's just be really careful. How do we solve? If you don't know, do step by step. Don't go moving that 12, because some of you are going to forget that this is a division. Undo the division. And legally get x alone. I'm showing you this because I've seen people do illegal steps trying to skip, and they just get all messed up. Can we plug into our calculator? No big deal? Okay, good.
Oh, hello.
Remember degree mode. Degree mode.
Degree mode. Someone had it. You guys were all excited getting the actual decimal. All right, fine. What's a shadow? Around 5 feet? 5 point what?
5.3, 5.4.
Wait, 3 decimals.
3, 6, 3, 6,
Fred Ortiz. 3, 6, 4? Wait. It's a word problem. What do we have to label? It's a whole lot different. Inches and feet. Next to each other. Okay.
Brandon never does anything wrong.
This is a
Yes.
jump.
Yes.
This is a jump.
I did not get 5.
No, you didn't.
We did not get 5.
Are you in degree mode?
Yeah.
I'm in rate. Oh, I'm in rate.
Wait.
Nice,
He said, I'm ready.
Nice, Sean.
Focus. It just got harder. Come here.
Whoa.
Wait. Where are the angles? So where are their triangles? Wait, do you see him? There's one triangle, right?
Oh, there's another one there.
Where's the other one?
There we go.
Whoa.
Misty.
Hello. Hold the phone.
All right. I'll code it. There's one.
But you
With the
know this
55.
one is 35.
But then,
And then where's the other one?
Use what Mr. Crawford used, the one that has like a bunch of colors.
Wait a minute.
Othering.
Who's that?
he's
That rainbow stuff.
Isn't he the heights wherever you go? If that's the plane, everybody's 10.
Everybody had low. Kind of like geometry.
Yeah, it is kind of like geometry, right? Like a picture within a picture. Now, wait. How far apart are the towns? Oh, hey, town 1, town 2. How far apart? We're going from the center of the town. X. Well, wait a minute. Our triangles are in the sky. How are we going to find this part?
We can find the whole and the small and then subtract.
Can't we find the adjacent of the little baby one? And the adjacent of the big one?
now I understand why there is.
And how are we going to find X? X equals adjacent to minus adjacent 1. Wait, no, this is ridiculous. How do I find adjacent given angle and opposite? Given opposite, you want adjacent, you better be using tangent. So you're going to separate these two and just do 2 little triangles where you have opposite adjacent angle. You use tangent on each of them. Take the bigger minus the smaller, and what do you got? big deal. Are we gonna get scared by those scary problems? Tomorrow. Tomorrow. Listen, I don't have a lot of notes for 4-8. So we're gonna work day it on 4-8. But wait, if you don't have 4-7, then is the 4-8 gonna help? No, you're gonna want to put it in your spiral. You're gonna get totally like us. That's right. So we're done 4-7 today. Work day on 4-8 tomorrow, and we'll be ready for our test on Friday.
Chocolate for $1. Chocolate for $8. $8? No, thank you. $8. Eric, your story is so funny.
Which one? Cracker? My dog?
No, your story.
Which story?
Snapchat.
My
It's
dog?
always so funny. No,
My dog's there.
it's constantly funny.
Oh, thank you.
Okay, so we did, tutoring.
Otherwise, they'll hear us talk about tutoring.
We did tutoring.